I'm sure somebody's come up with a title for it. The alternating series is, I think, the easiest one. Okay, first off, I think it's very easy to identify. Okay, so it's positive, negative, alternates in sign, or negative, maybe start off with negative. Right? But they always have the same structure in terms of the function. You have to have some negative number being raised to a variable power in order to have an alternating value. Right? So it has to take a particular form. The issue is sometimes it's hidden within there. So, like in the first example, it just flat out says you have -1 to the n plus 1. So it's screaming alternating series. But maybe it doesn't say -1 to n plus 1. Maybe it says -2 to the nth power. In which case, there's an implied -1 to the power in there that you need to flesh out. But anytime a negative number is being raised to a power, it leads to an alternating series. Fortunately, we have the AST, the alternating series test. All right. If these two conditions are satisfied, then we know that the alternating series will converge. All right. First off, the a sub n has to have a limit going to 0. All right. And a sub n itself has to be a decreasing sequence. All right. So that's pretty easy to verify. Because if you look at, well, actually, with the condition that you know what the hell a sub n is, right, in this context. All right. So if you follow the model, you can see here that it's basic. The a sub n is basically anything that doesn't involve the -1 being raised to the power. All right. So what I would do here in the first example is pull out the a sub n. All right. Now, what I would do here first, because it's usually a little easier to do this, is find the limit of this as n approaches infinity. Because listing out the terms of the sequence, I mean, it could be easy, but it requires you to actually list out the terms of the sequence. The limit part makes the listing terms of the sequence either irrelevant or relevant, depending on what the outcome is here. It converges if both of the following conditions are satisfied. The limit has to be equal to 0. It has to go to 0. If it doesn't go to 0, nothing else is relevant. All right. So this limit is going to 1/2. All right. So it only converges if the limit is 0, and the other thing, well, the other things are relevant. Therefore, it diverges by the AST, alternating series test. Do you have to say it again? No, no. Any constant is fine. If it's anything other than that, then you may have to do something with it. But if it's n plus 1, n minus 3, or just an n, that's fine. But if it was like n squared plus n, then you might have to take a closer look at it and make sure that, because it is conceivable that you, well, actually, is it conceivable? Let me see. If you had a fractional exponent, then you'd have a problem. It wouldn't be alternating series because you'd have a lot of imaginary stuff in there. So the only thing you'd want to do is make sure that no matter what you put in for n, you still only get a positive or a negative sign. Positive or negative 1. If that's the case, then you're good. And you don't have to worry about it. Okay. So for B, again, look for the -1 to the n or -1 to the n plus 1. Ignore that. Whatever is left is your a sub n. A sub n in this case is 1/n. The limit of that, because again, nothing else is relevant unless this plays out. Limit as n approaches infinity of 1/n does equal 0. All right, so we're good to go there. Now I just want to make sure that the first few terms justify that this is a decreasing series. All right, so And again, we're just doing this as a sequence. So 1 over 1, comma, 1 over 2, comma, 1 over 3. It is true that it is getting smaller, that the sequence is getting smaller the further you go down the line. So that satisfies this idea that each term, each additional term in the sequence is less than the one that came before it. The limit is going to, yes. A simple case would be 0 itself. Yeah. If you did -1 to the n times n minus 1, n minus 1, that'll give you the first entry at 0, so you'd still have a 0 in there. It doesn't end up at 0. I mean, I think it'd have to be like n minus n. So it would still, you know, equate to 0, but not be 0 itself. Oh, it's the end behavior model? Yeah, if you divide these two. So. Right, in which case you don't even bother. So. Well, that's the thing. I don't know that it would always be true because you could have something that, let's say, it oscillates back and forth. Well, it could be because you could have something. I just can't think of a function right now, but I can think of what the graph might look like. You could have something like so its limit going out to infinity would be 0, but it wouldn't necessarily follow the idea of always being a decreasing function. Right? So
wouldn't that still converge?
This would converge, just not by the alternating series test. Yeah, that's really what it comes down to. It's like we can determine convergence and divergence in a lot of cases just by typing it into the calculator and looking at the picture. It's just a question of what method would lead to it analytically. I just can't remember what, I mean, because it's like probability functions follow this path. You know, for the law of large numbers, you have a lot of oscillation and probability. If you do experiments, you know, like it's something simple like flipping a coin. You know, if you determine the probability of getting heads just by experimentation, you know, if you only did like 5 trials, you could get a probability of 1 or 0, something that's wildly different from what it ought to be. But if you try it 10 times, it's going to be closer to 0.5, 20 times even closer, 100 times even closer, 1,000 times pretty spot on, at least in the decimal form. So a lot of variation early on, but then as you increase your trials, it gets closer and closer to the true probability. That would be an application of something like this. I just can't, off the top of my head, think of a function particularly that would get us there. It would be some radical function. I'll figure it out. I'll just add it